So I think somewhere this problem suggests using logarithmic differentiation. When you have a rational function like this, where it's pretty complicated, um, you could take the derivative using the quotient rule and the chain rule and the product rule, and it's going to be really difficult to do it because there's a lot of steps, okay? So logarithmic differentiation will get you the same answers if you went that route, just in a much easier way. Before we do it, real quick, a couple of properties. If you take the natural log of two things that are being, or not just natural log, if you take a logarithm of two things being multiplied, it's the same thing as a logarithm of the first thing plus a logarithm of the second thing. If you take a logarithm of two things being divided, then it's the logarithm of the numerator subtracted by the logarithm of the denominator. And then if you take a logarithm of a number with an exponent other than 1, then that exponent can come down and multiply like this. Those are the three properties of logarithms we studied in pre-calculus. So the reason why it helps you here in this problem is take a log of both sides and you still have a statement of equivalency. These two sides are still the same thing. And I'll just put ... for all this stuff. Okay, taking a logarithm of both sides. And yeah, so like I said, it's still going to be the same thing. They're still equal to one another. So when you take a logarithm of the right side, it helps us because, look, this is like x in this example, and this is like y. So we're going to rewrite this as the natural log of the numerator subtracted by the natural log of the denominator. It's a minus. Okay, it's simpler. We're getting closer. Now I'm going to treat this like my x in this example, and this is going to be like my y in this example. So we can rewrite it as the sum of the two things. That's a property of logarithms. So this is natural log of 4x squared plus the natural log of that square root 2 minus 4x to the third. And then we're subtracting it by, we'll do the same thing. This is like the x and this is like the y. So put the whole thing in a bracket. This is natural log of e to the negative 5x, and it's plus natural log negative 3x minus 4, then end the bracket. I put it in brackets to remind myself that I'm subtracting this entire thing. So the brackets make sure we're subtracting that entire result. Okay, and a little bit more simplification. This is natural log of 4 times x squared. So again, this is like your x, and this is like your y in this example over here. That's now natural log 4 plus natural log x squared. And then here in this next one, this is natural log of square root of 2 minus 4x to the third. Square root is 1/2 power, right? So one way of rewriting this is you could take out the square root and just say this whole thing is to the 1/2 power on the inside. So if it's all to the 1/2 power, if you have natural log of z to the 1/2 power, that's the same thing as 1/2 natural log z. Okay? So in here, this is all to the 1/2 power. So I'm going to make the 1/2 come multiply outside. And now I don't have to deal with that square root. I've got 2 minus 4x to the third. Okay, and then continuing on over here in this bracket, natural log of e, those are inverses of one another. So those are going to cancel out. We don't have to use any special properties of logarithms. Natural log of e to the negative 5x, we learned in pre-calc, is negative 5x. And then there's nothing we can simplify here because look, all these rules are one term on the inside of the parentheses. This is two terms, so we don't have anything to help us out there. So this is plus natural log of negative 3x minus 4. Okay, and then we can break down the parentheses too. Minus a negative means you're adding, so this is now a plus. And then we got to distribute that minus sign, so this is now minus. A little bit of quick algebra there. Okay. So that bracket's gone. Okay, So now, believe it or not, it's easier than trying to take a derivative of that whole thing directly. Remember, this is all equal to natural log of y. So if I take a derivative of both sides with respect to x, excuse me, the derivative of natural log of y is 1 over y, but we need to multiply that by y prime because of implicit differentiation. When we take a derivative with respect to x, we don't know what the derivative of y is with respect to x unless we were to directly calculate it. So I'm putting in y prime here. Okay. And then on the left, going term by term, when I take a derivative, the derivative of natural log 4, that's just a constant, so that's 0. So the derivative of natural log of x squared, and actually if you want to make your life easier, you could move that 2 out too with using the properties of exponents. I don't know if that makes it easier though. Let's just keep it where it is. The derivative of natural log of x squared is 1 over x squared times the derivative of the innermost function. So the derivative of x squared is 2x. We had to use chain rule there. And here we've got 1/2, and then it's times the derivative of natural log of 2 minus 4x to the third. So that's 1 over 2 minus 4x to the third. But then we need to multiply by the derivative of the innermost function. So the derivative of negative 4x to the third is negative 12x squared. And then still going term by term, that's a plus 5x, so the derivative of 5x is just 5. And then this is minus the derivative of natural log of negative, so that's 1 over negative 3x minus 4 times the derivative of the innermost function, so times that negative 3. Okay, we're almost there. You just need to multiply both sides by y, which is just this stuff. So let's see, if we clean up the right side, it's not going to help us out much. This is one ugly beast. Let's keep that. Let me clean up the right side a little bit more. So this is 2 over x. And then over here, I'm going to multiply that 1/2. That's going to be 4 minus 8x to the third. Oh, I forgot that negative 12x. So that goes. We can just multiply up top. Yeah, that's easier. Let's do it this way. You got 1/2 times negative 12x squared. That's negative 6x squared. Still got 2 minus 4x to the third in the denominator. And then the derivative of 5, because we're taking a derivative of everything, remember? Wait, no, I've already done that. Sorry, I'm not taking the derivative. I'm just simplifying. So that's plus 5. And then minus a negative 3, so that's going to be plus 3 over negative 3x minus 4. Now, we don't have the derivative of y yet, right? We have 1 over y times the derivative of y. So you got to multiply y to everything to get y prime by itself. And remember what y is. We've got to multiply everything over here by y. Y is this stuff up here. This is hopefully the hardest algebra question you have in the course. This is pretty this is just, the calculus part's over. It's just algebra here. And it's not easy algebra. It's hard to keep track of everything. That's plus, so this is negative in the numerator, so I'm going to bring that down. That's just a convention, but don't have to. I would type this in Newton. I would just stop there, okay? Because this is correct, assuming I didn't mess anything up, like drop a negative sign or something. This is correct. We could simplify it. I mean, we could try to simplify it by distributing this to everything. Doesn't look like it's going to help much. This is probably where I'd stop. Let me go check. I'm going to go type this in Newton and make sure it marks